So start by the numerator. I always just, let's simplify the numerator, worry about the denominator later, and then combine it after. Okay, so that calms things down. So we're going to do here. The numerator. So cover it up. There's nothing, no exponents on the outside. So all we're doing here is we're doing multiplication. If we're doing multiplication, we're going to add the exponents. So add the exponents. So 20 and 5 are regular numbers. Treat them like regular numbers. Okay, don't treat them like anything different. 20 times 5 is just 100. That's it. Okay, so these guys here are just regular numbers. Exponent of 1. So just treat them like regular numbers. Okay, then here we're adding it. P to the negative 3 plus negative 2. Plus negative 2. So that would be P to the negative 5. Does that make sense? Negative 3 plus negative 2. And then we have Q to the nothing. P to the negative 5. My Q's too close. Q. Okay. I'm going to write down the denominator exactly as is. I haven't done anything. So I'm practicing what we just did before. Do you want it? We can shift it and then do subtraction if we have to. So I'm going to shift this one down here. So this one moves down, right? So the ones with the negatives moves down, and this one moves up. So this should be, oh wait, and the 100 and the 30. Treat that like just a regular old fraction question, so cover that up. With 130, can I reduce that? Yeah, divide top and bottom by 10. So, right, so we're doing divide top and bottom by 10, which I don't need to see. This is just your brain thinking this. So that becomes 10 over 3. Right, let's do that. So numbers are just numbers. And then I'm going to keep the Q where it is. I'll move this Q up, and I'll keep the P to the 4 here, and I'll move this P to the 5 down there. This one, I can combine it because they're both P's, and I can combine the Q's. See how I went back and forth in the types of questions? So we're going to go 10, 3. This will be Q to the 7 and P to the 9. And do I have to shift anything? No, because if they're not negative, we leave it alone. Okay, you only shift it reciprocal if you've got a negative exponent. How do you like the look of that one? Beautiful, right? You're like, wow, it's too short. Just kidding. We're going to make this one look like it's easy, though. So first thing I do is I don't like the radicals mixed up with fractions and stuff. I like to see the fraction so I can subtract better. So I'm going to switch all the radicals to fraction form. I'm going to leave this 2 out here like that. So I left the 2. This 4th root, that 4th root, so leave that out here. This 4th root is to the power of 1/4. Good. So I'm going to put 1/4. There you go. Okay, so that's this one here. That's this 4 right here. And we're going to go right here. So that's this one. Comes the 1/4 there. Okay. Then on the inside, so I'll do this one in the inside. And we have, so ignore this, ignore this. Now I'm just working on the numerator. Square root of 25x. What can I do with that?
You can move 25 to 5.
Yep, 5. And x to the?
1/2.
That's it. So they each get their own root. Can I do anything with the x to the 5 there? Not really. So this will be x to the, yes, invisible, 5/2. Good. Okay. The denominator, I'm leaving it as is. I can't do anything. So 30x to the 1/6. All right. So now, you were asking before about this. Should I reduce this stuff? 2/4 to 1/2? See this? Power to power. That's the 2/4. And I would like you to reduce it to the 1/2. So you had a perfect question there, right? So when you have this scenario, so let's just do the 2 outside ones. So doing this one out here, 2 times 1/4 right? 2 times 1/4, that's over 1, right? And that gets me 2 over 4, which reduces to be 1/2. So yes, I would like you to do 1/2 there, right? So that's those two there. So I'm going to circle those two. So these two here are my bubble here. Power to a power. So power to a power means you multiply. So I did 2 times 1/4, which gave us 2 over 4, and definitely we want that reduced to 1/2. All right. Now, so that gets rid of that. I'm still working on the inside of the bracket there. I want to finish up that numerator. Can I do more with that numerator? I think I can, right? So the denominator is kind of set, so I'm going to leave that one alone. But the numerator, I've got 2 x's. So I can add those. So I'm going to add these two together. So what's 1/2? Oh, and they are lowest common. Aren't I nice? X to the 1/2 and 5 over 2 is 6 over 2, which is 6 over 2. Do you want, sorry, 3. Great. It's like you're already saying it. Yep. Wait, yes, good. 3. Okay, so 3. So I added those together. Is that all right for here? So that's this one plus this one became the 3. All right, now what? Am I done? Numerator's done? Denominator's done? Yep.
My question is, why didn't we just, the step above,
Yeah.
or like on this step, instead of like reducing the half and stuff, why didn't you just multiply the half on the outside in and then reduce it?
Oh, bringing this in right here?
Yeah.
You can.
That's what I did. I brought it
Yeah.
in and I was,
Did you do the 5 to the 1/2 as well?
yeah, I did like everything that's on the top there, see on the one step above?
Yes.
I just multiplied that by a half, like everything, and
Yep.
the bottom too.
Yes.
And then I reduced the top one, and like added the x's.
Yeah, you can. Yeah, exactly. Right. That's why there's gonna be multiple. There's different method. There's different order. So you combine it after. Yeah. So you can bring in the 1/2 here, and then combine it after. I combined it, and I'll bring in the 1/2. Yeah. We should still get the same next step. So I think we should get 5 to the 1/2. Oh wait, do we want to subtract first then? Wait, which would you like to do? Subtract these two, or bring in the 1/2? So now you have a choice again. There's so many different pathways we can go with this. So I can either finish these guys and then bring the 1/2, but you already brought it in. 1/2 first. What about the 5 and the 30 though? Yeah, can I make those go away though? I kind of want that to become divide top and bottom by 5, so it'll be 6, right? So that's when you divide top and bottom by 5. Again, you don't have to show that, but you're doing that. So it's 6 on the bottom, a little bit easier. Okay. And then want to bring in the 1/2 now, and then subtract, or subtract in the 1/2. Yeah, 1/2 times 6. So that's why. You want to subtract then first? Let me try that. So I'm going to try this. So I'm going to go 3 minus 1 over 6, and then I'm going to leave this guy outside for now, right? So I'm saving that for later, and that's over 1, so 6, so it's 18, so 17 over 6. So 17 over 6. Then I'll bring the 1/2 in. Again, we should get the same answer. So this should be, you got 6 to the 1/2.
Yeah.
Yep, okay. And then x, 17 over 6 times, right, it's multiplication. So that'll be x top times top, numerator times numerator, and denominator times denominator, 12. 17 over 12 and 6 to the 1/2. That's it. And you're done. It's totally simplified. Yes?
Are you allowed to leave fractional exponents?
You're allowed, yeah, no, fractional exponents are beautiful. Yes. Yeah. I don't need you to change it to a radical. Yeah, so leave it. This is gorgeous. Leave it like that. Yeah, no need to change it to a radical. Yeah, fractional exponents are good. Just no negative exponents. Negative exponents, we want you, doing the reciprocal, flipping it over, but fractional exponents are totally fine. Yeah. Okay, so leave it as a fraction. All right, one more. No fractions, just negatives. Okay. Try this one, and we're going to go with, again, I like to finish the numerator on the inside first before bringing it in. You've got different orders of doing this. I can't simplify that, so I'm just going to leave this out here. Okay, there's too much going on. 3m to the 3 sits here. I'm going to just focus on the numerator first. Yeah. Okay, I'm going to focus on the numerator first. Again, just to calm it down, because when you see so many brackets, let me do what I can. So I'm going to start with the numerator. That there, again, is power. And make sure you know that's a 1. Right? So 4 gets its own negative 2. Does that make sense? Just be careful. 4 gets its own negative 2. And m2. Negative 1 times negative 2. Okay, again, your choice. You can bring in the negative and then do reciprocals, or do you want to subtract? So many choices. Okay, that's why you have to do nice steps, because I have to follow everyone's story. And so many different ways people do different stories. Some people go, oh, I did this, then I did this, then I did that. And it's the same pathway, it's just you took different turns at different times. So what would you like to do? Do you want to finish all of the inside first and then
Start with the outside.
outside first? Okay, bring it in. Okay, let's bring all this in. So to each 1, to the 3, and that. All right, so let's do it. So this will be 4 squared, m to the negative 2, 3 to the negative 1, and m to the negative 3. Okay, and again, right, different order, but you should still be following this laws of exponents. We're good to go. So now I'm going to do the flipping thing so I can get the negatives out. So I'm going to go, the only one that stays still is the 4 squared. I can make that 16 if you want. Want to calculate that? Might as well make it 16. So 16. And then I'm going to move this one, right? So all 3 of these move. So the 3 comes up here. The m cubed goes up here, and the m squared goes down there. So all 3 of those guys moved. And then finish it off. 48. M. And then m to the 3 minus m squared, so you're going to subtract, and I didn't need this denominator at all. So then I just erase that and go, oops, I was done. I was already done right there. Right, 3 minus the 2. Questions, clarifications?